tables is pretty important. And then we look to see if there are any groups under there that can be pulled out. If it's a cubed root, we're looking for groups of 3. I have one group of 3s. So I'm going to take out that group, and on the outside I'm going to put a single 3. What do I do with it? Multiply it times what was out there. Don't forget about the number in front, okay? Please, please, don't forget. This is 21 times the cubed root of 3. Y'all write quick because we got to start moving. What operation is taking place here? Multiplication. What do you have to do? Break everything down, okay? Instead of saying 12 times 27 is really big, and then breaking that down, break down 12. It's 4 times 3, and 27 is 3 cubed, correct? I still under there have 12 and 27, all being multiplied together. And then I try to identify, it's the square root, so pairs. I have a pair of 2's, a pair of 3's, and another pair of 3's, with nothing left under the radical. 18 is the answer to this one. When you see this problem, your brain should register a word.
Distribution.
Distribution. I must distribute. Radical times radical, whole number times whole number. All right, here I go. When I multiply here, I have -2. And under the radical, I have 3 times 6. Now, why would I do it that way? Because I'm ready to simplify now. Okay, but I'm going to keep going first. Then when I take this and distribute here, I have negative times negative gives me positive. There is no whole number, it's 1. And under the radical, I have this 3 multiplied by 63. What's 63? 9 times 7. Right? Okay, what can I take out of here? Have a pair of 3's that I can remove and combine with the number outside. Here I have a pair of 3's that I can remove. I put the 3 and the 7 back together to make 21. Can I add those together? No. Now I will have a choice in the test that says -3 square roots of 23, and I bet you somebody's going to choose it. Okay? You cannot add that together. They are not alike. You have to know your rules, or I'm going to get you.
So if it was 6 square roots of 21.
If it was -6 square roots of 21 plus 3 square roots of 21, then you could put them together, and you would get -3 square roots of 21. Remember, the radical doesn't change. Now here, your brain should say FOIL. First times first gives me 25. Outer times outer is +5 square roots of 3. Inner times inner is +5 square roots of 2. And last times last is the square root of 6. Now I didn't write it separate because I know nothing's coming out anyway. Can you add any of that together? No. All 4 of those terms are different. They stay separate. Just because there's 4 terms in the answer doesn't mean you did something wrong. They're just not the same. I asked you to simplify this fraction. The first thing is this. Since they're both under the same radical, the first thing is, can I reduce 4/7? No. All right? Then let's get that 7 out from under that radical in the denominator. It's the cubed root, which means I need 3 7s to be able to get it out, right? I already have 1. I need 2 more. Okay, so I'm going to multiply by 2 more 7s under that radical, and that means I need to do the same thing at the top. When the numerator, is anything going to come out? No. You've got 2 2s and you've got 2 7s, but you're looking for a cubed root. So we're going to put that together. And it's going to be 49 times 4. Which is 196. And in the denominator, what's that going to be? 7. Can you reduce 196 and 7? No, no, no. All right? Can you reduce 2 and 2?
No.
No. You can never, ever, ever cancel a number that is under the radical with a number that is not under the radical. One of them is a whole number, the other one's a decimal. Now, if I had this, could you reduce something?
Yes.
You could reduce the whole numbers. What would this give you? 2 square roots of 2. Because the whole number 4 divided by the whole number 2 gives you 2. All right, and we spent the whole first period of the whole first part of class going over this, but we'll go over this one because we're running out of time. Can you cancel that 3 with this 3?
No.
Why not?
Because it's part of the thing
It's
under
its own group.
Group. Group. Okay? Don't just cross them out and go with it. Got to know your rules because I will give you one of those as a choice as the answer. So you better know your rules, Blake. All right. What do you do? I multiply by 3 plus the square root of 10. All right? In the numerator, we've got to distribute. 3 times 3 is 9. 3 times the square root of 10 is 3 times the square root of 10. In the denominator, I've got 3 times 3, which is minus 10. What's 9 minus 10?
-1.
All right, but we don't want a negative in the denominator. So I'm going to distribute it to all parts of the numerator, which means your final answer here would be -9 minus 3 square roots of 10. We have 2 more minutes. We can get another one in. All right, so the final answer to this is, what is that? Can you cancel anything?
Yes. No, it's a subtraction problem. I mean, it's addition to X.
Group divided by group. One's the sum of, the other one's the difference of. Can you cancel that? No. No. 3 plus 4 divided by 3 minus 4. Is that the same thing? No, that's 7 over 1. All right? 7 over -1. The denominator, only one part is under a radical, so I'm going to multiply by the opposite of minus. I'm going to multiply by plus, which means I'm going to do the same thing up here. Let's work on the numerator first. We've got to do FOIL. X times x is x squared. My outer terms multiply to give me plus x square roots of 5. My inner terms give me plus x square roots of 5. And my last 2 terms multiply to give me what? 5. In the denominator, I've got x